Welcome back, everyone, to this mini-series on copper for drones. Right? The goal of this series is basically to build copper, our robotics runtime, and make it fly on those aerobatics drones. So this is part of the series. There is a playlist, and I'll link it below. This second episode will be about setting up the toolchain to be able to compile on our target hardware. Right. The first part we went through how to set that up and check if the camera was working and so on. And let's get to coding on this episode. So what we want to do is what is called cross-compiling. Cross-compiling means that here you are on an x86. If I do that, right, you see that we are on a PC, basically. And what we want to do is to target our little platform that I set it up as Copper 8. And if you look at what architecture it is, it's called Arch 64. Arch is like ARM architecture 64. So those are not compatible binaries. You cannot just compile on your local machine like a standard binary, ship it to the machine and run it, right? They are completely different. But at the same time, we don't want to compile on this little machine, right? It's a really small machine, and it will take like forever to compile, especially like Rust. Rust is a little bit heavy to compile, so don't do that, right? So it's better to take a little bit of time up front to set up your environment so you can gain time after during your development. So let's get into it. The first thing you need to have, so there are like two levels. There is the kind of the tool chain, like the assembly compiler, C compiler, and so on for your target platform. That's one level. And the second level on top of it is the Rust target. Basically, the Rust compiler also needs to be able to produce something that the linker and the assembler and so on of the platform can actually compile an executable from. So the first thing we need to do is to basically determine first like which platform are we talking to, right? So what I was saying with uname.a, like what we saw, you have like just like a brief overview of what it is, right? If you do ls CPU, you have this command. You have a little bit more details about it. So you see that, okay, that's the thing we saw. It can run in 32-bit and 64-bit. So be careful, right? Like here. So depending on the platform, if you really have like a very, very small platform, sometimes 32-bit is better because the executables are smaller. But here we have something a little bit more intermediate, and we will aim at directly like 64-bit. So that's something you need to note when you are trying to find which tool chain you need to actually target for your application. That could be important, but now that's a default, like the ordering of bytes in a multi-bytes world. Okay, all those. So it's ARM, like we said. That's just like the general level of the ARM platform. What you need to check, especially on ARM, is that some platforms, like especially small ones, do not have floating point accelerators, which is kind of scary, right? Like if you want to run Copper without like a floating point platform, I would not really recommend that. But and other things, right? Like so, for example, like if you look at that, it means that your FP means floating points. It means that your CPU, your ARM CPU, do have an accelerator for floating points. And the other ones are interesting, like for example SIMD and so on. So those ones are also accelerations we will be able to actually leverage, especially with robotics algorithms on the target platform. So okay, we know that we have hard float and we target 64-bit. So let's go back to our machine and install the correct low level, the lower level side of things. So for that, So I'm lucky I'm on Arch Linux and everything is accessible out of the box, so you might be less lucky. But what I'm trying to install here, so is basically a cross compiler, so the toolchain that is actually an x86-64 executable as a compiler that will target an ARM as the output. Okay, that's what it means, cross compiling. And what I will do, because like on that platform, it's Debian. So Debian is like so old in terms of like glibc and so on. And if you try to match those modern like tool chains with the one you have on your platform, you're about to have a really bad day. And the only dependency between those tool chains and your target platform is the libc, basically the interface, the POSIX interface for the applications to talk to the OS. And usually Linux use glibc, but glibc is GNU. So GNU has like a license, a very well-known open source license, and you cannot actually. I mean, if you are actually like statically compile glibc with your application, you'll need to basically open source your platform. And so the industry came up with a solution, and they rewrote like a libc called musl. You see there, and so it has like a licensing advantage. So musl is completely free. You can completely statically compile. And for us, it's cool because then you have one executable, there will be one copper executable, right? Your application, and it will be completely self-contained, right? It will only talk to the ABI of the kernel. So this is what we want. We want the musl one on Linux, and that's the ARM64. So let's go to install this thing. So why? Oh, yeah, sorry, no, it's dash S to install. I was a little bit confused. Okay, so now, we did the low level. Now we need to make the Rust side of things. And Rust, you have like the Rust up tool. So if you haven't installed it, you go to rust.sh and you can install Rust up, which is basically the package manager for the Rust toolchains. And once you have that, you can execute this command that will give you the list of the installed toolchains, right? So I have a bunch of them because working with Copper, I have a bunch like for like, I don't know, RISC-V, ESP, and so on, like a bunch of things that I tried. But I don't have the correct one for this platform. So let's go for it. It's exactly the same name, like this. So Arch is for unknown, it's not the same name, unknown Linux musl. And that will install, okay, you're basically your Rust compiler for this platform. Now, we need to tell Cargo, which is the kind of the make building tool for our Rust. Okay, if I target that like that Rust target, which toolchain I should use to do the low-level libc and linking phase. So you do that by editing like a config in Cargo. But first you need to determine what is the GCC that is used by that low-level cross compiler. So okay. So I do that by basically querying the package manager straight here in Arch, and I try to find this guy here. Okay, that's the GCC. The GCC for that platform. Okay, so now that we have it, let's edit The file is in .cargo/config. Yeah, this one. And here you do target. So dot. It will be arch 64 done unknown. Linux musl. Right, so basically it tells the compiler for this target, use this linker, and actually it guessed it correctly. Yeah, that's the correct one. So use the command we determine from our package manager. So that should be enough to compile locally a binary for that platform. So let's try. So let's go in a temp directory and do like a little test app. So when you do that with Rust, it gives you like an hello world, right? So you can test it immediately. Cargo run, up hello world. Compile locally on my machine, right? We haven't compiled for our target. If we want to compile for our target, we need to specify when we compile it, the target. That's the same one. So usually I make myself, and you'll see that actually in the Copper repository, I make myself like little shell scripts to do that, because it's kind of a pain otherwise. So you don't see my prompt actually. Okay. Here you go. Here we go. So yeah, we precise, yeah, simply the target there. So what it produced is a binary that we can execute on our platform. So if we look at inside the release folder, yeah, that's our executable. If you do file on it to check, yeah, check that out. It's not executable for your platform. It's for the target. So let's copy this file. Okay. To our machine. Okay, and then SSH into it. Should be there, yeah, and execute it. Here we go. So we compile this Hello World program on our platform, on our desktop, comfortable desktop, and we could execute it on the robot, like what's going to become the robot. So that was like a basic step for us, and the next stage is going to be, okay, now we need to build our Copper applications, and I will do that in the next video. Thank you.